Welcome back to the Net Podcast. Today we have a treat for you. As usual, you're with Dave Tucker, Kyle Mestry, Tom Nadeau, and me, Brent Salisbury. And we have the intrepid, the one and only, one of the OG podcasters of our time in networking. It is Mr. Greg Ferro. Hit the applause button,
Packet
Dave.
pusher.
Hey guys, how's it going? It's been a while since we last caught up with each other. We used to see each other in meet space, and we haven't really seen much of each other since. How you been?
Good. Yeah, those days were bad when we had to travel and interact face to face.
Yeah,
right.
So
it was better than working though.
Conferences and stuff. Wow.
Yeah, it's true.
To go to things in person, man.
Yeah.
We were just bemoaning all the travel. Yeah, the travel to get there. Oh.
Yeah.
Takes
And
life off your years off your life, without a doubt.
Are you guys planning to go back on the road? Like, are you cutting back or returning to normal, or are you telling your boss that Concur is so miserable that you're just not having anything to do with it?
I went on my first trip in 3 years last week, and it was okay. I mean, I agree with you. I wouldn't want to be doing this every week again like I used to.
No, it's terrible. I was gonna go to the Linux or to the open source summit in Austin, Texas this summer, and I at the last minute couldn't go because I had scheduled it with some personal thing. But the people that did go, it seemed like a disaster. None of them got out of there on time. I mean, the ATX airport's a train wreck outside of coming out of COVID, and it's terrible now. So
and once you get to the session, they're still playing pre-recorded videos and stuff. Like, why did I go travel 3,000 miles? You know?
That's right.
Dave,
exactly. I heard about that too.
Everybody came home with COVID, right?
Yeah, I only did one day though. See, that was the smart thing. I went in for what I needed to do and then came back and avoided all of the plague. But traveling in Europe as a non-European citizen now, not trying to get political, is somewhat difficult, and even more so because of the trouble at the airports. But I am going to be on the road again in September for Open Source Summit and Linux Plumbers Conf and another Red Hat conference in September. So fun times.
Look at you! Wow.
Yeah.
That's
Dave, I'm glad you're doing it
out
because
there,
someone
man.
has
Be
to
careful.
Yeah.
Someone has to do these things, right?
Well, it's just become too. For me, it's become too time intensive. It takes too long. If I go to America, it's I lose 2 days just in travel there, and then I lose 4 days when I get back to jet lag and function. Yeah.
Yeah, if you're lucky and your shit doesn't get lost, then you end up in the wrong place, and man.
Yeah. So, and then put on top of that the airports at both ends are having problems. Just doesn't seem a smart use of your time. I've got, chairs to sit in and beers to be drunk, and I've developed some new hobbies in COVID, during the COVID period. And, honestly, sitting on a plane might have been my hobby before, but maybe it's not now, and the world has changed.
Cool. Yeah.
Excellent.
So what are you up to these days?
Speaking of, like connectivity has become more important than ever, and it's arguably worse than ever. So, what are your thoughts there? So as work from home becomes, especially in technology, somewhat of a de facto.
Well, we used to talk a lot, right? And we used to talk a lot about WANs and MPLS and how, connecting things together. One of the things that I've seen lately is that the use of telcos have become non-important. They're no longer a discussion point. And that whole MPLS WAN is going away. So I was looking at some research from Telegeography, and they're saying that the MPLS market is decreasing at a rate of between 10 to 30% per annum in size. People are just saying switching from MPLS to internet. Maybe they're using DIA, so using the same tail circuits to get internet, but a lot of people are just shifting to consumer broadband or cable, dropping some SASE or some sort of SD-WAN on top and getting a better product. So one of the interesting things here is that I call this connectivity is armpits. Everybody's got armpits. It doesn't matter. In the days before, when connectivity wasn't armpits, like when only certain companies could afford to buy connectivity, and we used to make these WANs that looked like OSPF networks with stars, point to point, because OSPF was so unreliable and so unstable, we couldn't make a mesh. But when we do SASE / SD-WAN,
for private use, right?
Yeah. And so now we just replace them with SD-WAN and SASE, which can be mesh, partial mesh, half mesh, any mesh. It can be meshed for voice, but not for everything else. You can have local breakout. You can send it off to the data center if you want or not want, whatever. And the whole idea of MPLS as a future is gone away. And I think we don't talk enough about just how much we don't care about telcos anymore and how telcos don't actually figure in the IT strategy like they did 3 or 4 years ago, right?
Did he just say that out loud?
He did. Well, I mean, and so I do think there's been a trend for, it's almost, I would almost say service providers did some of this to themselves, right? By making like these products like with so much complexity and so much like high touch. So it used to be, you pick up an MPLS VPN from a vendor or just, MPLS circuit is what we called it. So you'd have some kind of peering or static routes into that. So each of your spokes now have these static routes. More than likely, if you're small, a regular size enterprise with, let's say, 20 remote sites, every remote site you add on, you now have these, new static routes, and now have to call the service provider, get them to add routes to all the sites. That never works, right? There's no way to validate it in time. Because, you don't have any testing. There's no rigorous testing in any of this, right? It's like I can ping headquarters, good to go. But I can't ping my, 5 of them.
Well, and the other thing is there's been finally a realization that a VPN is not as secure as you think it is, right? Everybody thinks they're wrapped in this nice blanket, and instead, instead you have to authenticate to all the services inside of the enterprise anyway. So why don't you just SSL everything? And then it's just
right. So that,
the
I think that leads to this conversation of what's the end game? Is the end game, zero trust networking potentially, right?
Yeah.
But it doesn't mean
simple.
you throw out the baby with the bathwater. But to Greg's point, like commodity internet was always good enough. It got to the point where commodity internet was just so damn cheap, it made no sense to add the operational.
My views on this. The answer is bandwidth solves all problems in networking.
Exactly. I was just going to say that.
If you could buy a 10 meg MPLS and replace it with 100 meg internet, doesn't matter what the shortcomings are of an internet service, that last hop at 100 meg is not just 10 times better, it's 100 times better because you don't have any congestion at all. And what a lot of customers are doing is switching out 10 meg MPLS for gig tail circuits with 500 megs of CIR. And all of a sudden, transformational, like printing they don't need QoS anymore because even printing works on 500 megs, right, on a gigabit tail circuit. And
even with a little loss, it's still fine.
Yeah.
Remember when WebEx and things like that first started coming out, and they were like, "Oh no, you need a CBR circuit. This is impossible. The video won't work." Oh, look at us now.
It's just interesting to me that. And what we're also seeing lately is the rise of unreliable telcos. So we saw the Rogers outage last week. We saw Comcast have a massive outage about 3 or 4 months ago.
Facebook thing a couple of months back.
Facebook went down. We've had similar situations with Japan. We lost one of their major telcos, was down for several days. I think we're getting to the point where people are starting to realize that you actually can't trust a telco. The idea of 5 nines, that's gone. And that doesn't matter whether you're an MPLS backbone with a private dedicated circuit with a so-called 5.9 update. You actually want multiple telcos to have stability. And increasingly, because a lot of branches now, only some of the data goes into the corporate data center. A lot of it goes off to Azure or AWS, or maybe you're doing some sort of cloud-based SASE, where it's being logged and secured and scanned.
But that's what I mean by authenticating to the services, not to the place anymore. And that's really, that's what I'm talking about. Like Azure, AWS, whatever, you authenticate to the service and then it works, And
then, but more importantly, I think the thing that's slowly becoming more obvious is that we don't need the telco's permission to connect things together. Like we set up this call today and we're all connected together on an app. But I didn't have to go to my telco and say, can you please set up a circuit between me and this company, and this company so that I can set up a video conference call. The thing about the internet is that it's a permissionless environment, right? It's one of those things where if I want to connect to anybody, I don't need your permission or a telco's permission to be able to do this. And I think people, and this is probably the thing that SASE and SD-WAN that people have missed, is if I want to deploy Salesforce and buy it as a SASE, if I want to buy, any of these new SaaS services that are out there where, for data management or data analytics, I just connect to them over the internet. I didn't have to go and configure a direct connect or an MPLS tail and
special firewall config. Remember that thing like at an enterprise. Now let's go configure 50 firewalls, or if you exit this way, but nothing works. And
I can just go to the SD-WAN and say and then go to the SDN platform that's integrated in the SD-WAN and say allow everybody to access Salesforce. Tick, press, bang, done.
Boom.
And it's all done for you. All the IP addresses, all the application inspection rules, all of the access lists are automatically updated. If the app changes, it's the cloud platform that the vendor provides updates all that rule. It's a real transformation.
That's the unintuitive part because it's actually simpler operationally and simpler and cheaper to operate. But the traditional IT ops thing was like, no, I need control of everything. It needs to flow through here and
And I just think that's missed. It's something that's been on my mind lately, is that when we talk about MPLS, telcos are all really bent out of shape. You've got to have MPLS, and I need quality of service, and I need time, and I need to have fast reroute to have 50 million. Nobody cares. Because, as long as you're, in the mod, we know people don't care because if you're talking to somebody on a mobile phone and the call drops, do you throw your toys out of the cot? No, you just ring them back. Yeah. So I just think that there's all these angles to this. The internet is better than MPLS in almost every way, except for the lack of guarantees. And, that permissionless stuff, the fact that I can connect to anything, anywhere, the fact that it's cheaper, so I can buy 10 times as much and still save money. The addition of access to security services, like I can send it out to a cloud-based hosting service to do all the scanning for viruses and logging instead of routing all that traffic back to the data center and routing it, and scanning it all and all that sort of stuff. And then, all of those things that used to painfully, just cause us so much pain. I think MPLS is not just dead. I think it's just irrelevant, right? It's one thing to say it's dead, but it's not even, it's just fading to irrelevance and at a very, very, very fast rate.
So one thing I think that gets lost in translation in that messaging, though, is so that's from a consumer perspective, in my opinion. So like if I'm going to go, if I'm a customer and I need remote sites, MPLS, dedicated MPLS circuits are probably not the approach I would take today. If I'm a large enterprise or if I'm a service provider, MPLS VPNs are still quite important in my opinion. So do you disagree there? You're saying we completely throw out the... Yeah, I mean, like L3 VPNs are I mean, there is no cleaner way.
Core too, right? I mean, in the cores of these networks, that's not really, I don't see that really changing right now. But you're right, Greg, like that. But that's also what's happening is the action is moving to the edge anyway, as always, right? This is the never-ending movie, right?
Here's an interesting question for you. You guys would be probably the people I would ask this. The point here is things are moving to the edge, but are they moving to the edge because TCP/IP is inherently an edge-based architecture, or are they moving to the edge because it's a reaction to the public cloud? So if you think about public cloud and how expensive it is and how difficult it is to operate a public cloud, and that's what we're starting to see is people are starting to realize the public cloud is not, our Lord and Savior for
not the nirvana that it was chalked up to be.
Yeah. And so one of the things that I'm seeing with the edge is this a reaction to the fact that the core is dominated by, a handful of companies who are willing to spend tens of billions of dollars a year to dominate the market. So basically, AWS is at the point where it's just spending $44 billion a year to dominate the market, right? And at some point, it has to make a profit, but not yet, right? Or are we going, and so this drives competitors to the edge, which is anti-cloud. Or are we going to the edge because it's inherently, as part of the HTTP protocol, which is I think layer 3 networking is completely done. We're already networking at layer 4. Everybody's doing everything over HTTPS, right? Doesn't matter what you do, API calls, VPNs, SD-WANs, web browsing, app control. It's all HTTPS over TCP or QUIC, right? And that horse is bolted. There is no layer 2, layer 3. It's all layer 4 networking now. But inherently, HTTP is an edge architecture, right? So are we moving to the edge because the underlying technologies are inherently edge, or are we moving to the edge because the market sees that as the only competitive space left?
That's a good question. I mean, part of it is,
I'm good at good questions.
How else can we cram more complexity into the network if we don't disaggregate every single bit of it to the edge, right?
Yeah.
What are we going to do with ourselves if we don't make that opportunity for ourselves? I mean, but I think we've naturally seen it, right? Services used to be in the core, slowly moved out to distribution, provider edge.
Well, also the services were hosted in the core too, and they can be kind of half hosted on the edge and half hosted in the cloud, and that's maybe that's the same client server architecture that Greg's talking about, just shifted over here, right? But what does that mean for the network over here? It means all you're doing is getting me from here to there now, not like you're not hosting anything inside really. And that's what you're seeing too, like in the simplification, the ever never changing simplification of the core. Pushing stuff to the edge from the core. This has always worked this way, at least since I've been working on this.
There's a pendulum, a cycle, mainframe centralized, move to PCs at the edge with the mainframe in the middle, move to servers and
the same with the capacity network too, right? Yeah. Used to have like the big honking core metal at the time, and then 5 years later it's slow. Now it's an aggregation box. So now it's an edge box, and it's.
And then we put all of the servers that used to be in the branches back in the data center because we had enough bandwidth, and now we've moved them all even centralized. The data centers are centralized into the cloud, and now we have something swinging back to the edge. It's an interesting, is that a persistent trend? The industry swings backwards and forwards as the underlying technologies adapt, or is it because?
I mean, you're also seeing an evolution in server architecture to kind of mimic this too, right? This is kind of Kyle and I are working on, the kind of evolving DPU NIC thing that's going on in the industry. And that's also going the way it is, much in the way the network is, I think, to tailor, for those use cases now. Like, the way that we're doing is really, we're moving that stuff out. It's partially at the edge. It's partially at the cloud. It's not stored here anymore, but it's got to get there. I mean, I think that's what's driving a lot of that too, from that other end. Not just the consumer, where the consumer wants to be.
It also depends on which vendor you're talking to in terms of the edge, right? Whether it's let's call them legacy vendors or the cloud vendors. And I think the best thing, which people maybe don't realize, maybe they realize it now, but a few years ago when we looked at Amazon's, I forget what it's called, but their thing where they'll drop like a bunch of compute somewhere and you can use
Outpost.
Outpost, right? Yeah, I forgot the name. The best part about Outpost for Amazon was, so you pay to lease the equipment that they drop in your data center, and then you pay to run the VMs on the equipment that you're paying to lease. So from their perspective, it's fabulous because you're covering the cost of the equipment up front, so they don't have to amortize
and the ops
anything, and you're running everything. So it's brilliant, but so you got to be careful, right? Because I think the other thing we should talk about a bit is, are we eventually heading into a world where there is no internet, and really there's Amazon's network, Google's network, Microsoft's network, and Facebook's network, and those just connect at certain points, right, as you go across them. But, I think if we're not careful, in another 5 years, God help us if we're still doing podcasts, we'll be talking about that.
Well, they do account for a majority of the internet traffic now, the hyperscalers, right?
Right.
So it's
and their own private backbones are bigger. There's more bandwidth inside of their networks than there is on the whole public network. However, but that's also true if you think of all the private train lines, like that's reflected in normal life. If you think of all the private transport operations that are out there and the public highways, the same sort of thing exists. Public highways have a purpose and they exist for a reason, but there are private train lines that are longer than any any other train lines in the world.
And private jets and stuff, yeah.
And I think also one of the benefits of capitalism as a business model is that the idea is that businesses which go stale don't get to sit and take rent extraction. So the original idea behind capitalism in the late 1700s, early 1800s was that we had capital invested in land. So if you owned land, you were rich because everybody else worked for you to farm and right.
Yep.
And so the original idea behind capitalism was to make poor people better off. So what they did was they said, if we free up the capital, people will start to make factories. Poor people can work in factories. We can have money no longer derived, and there's an innovation, and then products will then improve people's lives. And so it proved out that, it wasn't perfect and it took a while, but inherently. So what we want to have is a situation where companies like Google and Facebook can die, and those resources, are replaced by something else. And that's ultimately the key of the internet is the standards are public, the implementations are proprietary, AT&T, Verizon, BT, those companies have all been disrupted because they're miserable at running networks, and small companies come along. Facebook can do a better network than BT, which is deeply amusing considering how dysfunctional Facebook is.
Yeah.
So what comes next, right? Who comes along next?
So
with
that's a
something
good
better?
point. That one of the original tenets of the when you talk to I've worked with a lot of these folks that really started the internet. They were working on DARPANET and all that. I mean, very good friends of mine, and they tell me that there's a few tenets that still exist and it's good, but what Kyle was saying, like the ever distributed nature of the internet is why it works, right? It's the non-centralization, and this is what worries a lot of people is the kind of semi-centralization right now.
Yes.
I mean, around if you take the top 10 kind of hyperscaler / DC folks, that's where 80% of the internet traffic is.
So keep in mind that the death of MPLS is a decentralization cycle.
Yeah.
Right? Because it means that now Rogers and AT&T and BT and France Telecom can't dictate who you connect to. They can't dictate the pricing.
We still
and
carry
the market
on,
is, but they can continue to innovate and develop, and hence why they're all pushing into mobile networking, because that is more closed and they can create a captive networking. But that is also being, and equally there we're seeing governments
open as we speak too. Yeah.
That's
exactly.
right. Open RAN, the rise of software-driven infrastructures around 5G and all that sort of stuff.
Yep.
So I actually see the death of MPLS as actually being, the death of the previous, closed.
It's just an evolution of what's going on, really. It's not a horror story. It's an evolution of.
Yeah. As long as I think the key here is as long as there is some sort of governing body that keeps the decentralization option open and prevents the closing. So, for example, in the US, for example, AT&T and Verizon have a virtual lock on the market. It is very difficult because they have a legislated governmental mandate to dominate that market. And they are supposed to be giving things back to society. That was the original idea. But that's not how it's turned out.
The same with cable, too. It's a regulated monopoly, basically.
That's right.
Yeah.
So what we don't want to have is regulated monopolies on the internet globally. And eventually, at some point, the rest of the world, AT&T and Verizon have found they can't compete globally, receded to the US by and large, and eventually at some point they'll go broke because it just doesn't make sense to keep doing business the way that they do. Even if they have a monopoly, there'll be some way eventually. Like the internet, as the internet progresses, those businesses struggle. Like we're seeing the death of video over cable, the great, what do they call it?
VOD.
Yeah, the unbundling of it, the death of subscribers, they call it. And they're talking
the cord cutting. Right?
Cord cutting,
the cord
that's
cutter,
it.
Yeah.
And they're talking 3 to 6% loss of subscribers every quarter in those businesses. And
that's pretty incremental now. I mean, there was an avalanche for years. I mean, when I was at BT, this was already happening at BT in 2007 when I was there. We were seeing 100,000 subscribers lost every quarter. And cable was seeing that too across the globe. I mean, that's a lot of subs. And 10 years, that's a million subscribers that are gone.
Yeah, and each one of those subscribers was paying $70 to $100 a month. That's a lot of money to spend. I think one of the other things I wanted to talk to you about was the death of big announcements. Do you remember 5 years ago we used to go to, and we used to have like new chassis announced, and we'd all be like,
right.
oh, silicon hardware. sucking fans and all that sort of stuff.
Right.
One of the, I'm not, when subscriptions arrived and this idea of software as a service, and now we have networks as a service and subscription pricing, and shareholders think that subscription pricing is the best thing ever. And I can understand it from a shareholder's point of view. I'm not necessarily convinced that customers are well served by subscription, but one of the things about subscriptions is because you pay for it every month, or every quarter you send your invoice, you get an invoice from your vendor or reseller, and you send it off. It changes the way products are put together. And like if you've got a switch on the ground or a router on the ground or some sort of firewall, and you're paying for it every quarter, do you know what you're doing? You're looking for something from that. Like every month when that money goes out of your bank account,
you better be getting your money's worth, right?
Yeah. When you pay your Netflix subscription every month, you go to yourself, do I really need this? Oh, yeah, I definitely do. And compared to the old model, like we used to, once every 10 years, we'd be off buying a data center switch, and it'd be like a year-long process of, arguing over how many ports you need for the next 10, all that sort of stuff. Whereas now the vendors are talking about a 3-year cycle. They're saying that customers are now buying data center switches on a 3-year. I think.
Well, or not just buying, like you mentioned the subscription thing. All of the big hardware vendors, certainly the server ones, will lease their equipment. They've been doing this for a couple of years now. And it's interesting how it changes the dynamic of what you're saying. Like suddenly it's, when you talk to the telcos, it's no longer, like you said, I've got to buy some more hardware and I'm going to rack it up and whatever. And, we'll pick, I know it's more expensive than everything else on the sheet, but, I like this vendor better or whatever, whatever that crazy stuff that goes on in the background. Now, conversation is very pointed. It's, okay, how much is this and what's the ROI and how am I going to amortize this thing? That's all in the same conversation now.
Yeah.
It's really interesting.
But the flip of this is no more big announcements. So, for example, recently was briefed by Aruba on their AI ops. And the point is that we've been briefed on their AI ops for over a year now. And they've made like 100 releases, feature releases into the product over that time frame.
Yep.
But nothing really like big, right?
No splashes.
If you're a customer of that product, you'll actually. So it's interesting, as a customer of that product, it's getting better all the time because it's hosted externally, it's in the cloud, they deploy it, the models improve, the training improves, the data collection gets fed back into the models, etc.
But that can go too far, right? I mean, I have the same thing. My car operates this way, right? And I've legitimately seen improvements, like places where like it wouldn't drive automatically, and I went by there a few times, and a month later, it works. But there's a dark side
from a marketing point of view, and if you're trying to find out what's happening with a vendor, where's the features? Where's the special release? Where's the big news? How do I make a splash and get customer attention? It's really interesting.
Very rare. Like the big announcement is very rare, But the flip side of this is. Go ahead. Sorry.
I think part of the reason, though, is all of those vendors that did those big announcements, right? I mean, they're all on the downswing at this point. The reality is, and like you said, they're moving their products to the cloud and everything's like that. But then you look at the cloud vendors. I mean, let's look at Amazon. Amazon releases so much crap. There is no big announcement because it's like a stream of stuff. And it's gotten to the point where there's no big announcements. There's just thousands of announcements
thousands of small announcements.
Small announcements,
Only small announcements. Nothing big.
That's right.
There's
it's kind
nothing
of like
big.
Agile has taken over products completely, right?
Yeah, that's right. Yeah.
So maybe it's the cynic in me, but I do also wonder if one of the same forces driving this wedge is also one of the forces, which is the lack of big announcements, which is this kind of plateauing of Moore's law. Like there has been nothing exciting from a hardware standpoint in the last 4 years. CPUs aren't getting much faster, There has been no, look, now we've got IPUs and we can accelerate this really like niche thing now so that we can do the thing a little more,
I don't know, faster. Dave, I think Apple Silicon is like, that might have something to say to you there, because I would argue that that's a pretty phenomenal hardware.
Yeah.
Thing. I don't disagree, but my point is it's not groundbreaking.
But an SOIC
it doesn't enable anything else that it didn't do before. It's better and it's more power efficient, But if you compare an M1 Mac to the previous generation Mini or the next version, like, is it really that much better? Is the camera, oh, look, the camera is a little bit better than it was the last year. I think we're just having these minor incremental improvements and nothing really earth-shattering like we were seeing before, of like, oh crap, this silicon is like so much faster. I can now switch at like multiple terabytes as opposed to multiple gigabytes. Like, we're just not seeing those big technological leaps. And I think
it was like Greg was saying at the beginning, you know, like we used to be starved for bandwidth. And I remember when the T series, Juniper T series came out and the CRS1, people were like, holy shit, this is like all the internet's bandwidth is in one box right here.
Yeah.
Right? Look at it. You know, I mean, it was like, woo, we finally got this working, right?
Yeah.
But we haven't had one of those in a long time.
Well, so here's the thing. Juniper just announced their new series, and that chassis can now do over a terabit per second.
Yep.
And handle 32 by 400 gig ports, a single blade. Sorry, not just a terabit per second. It's like 300 terabits per second in the chassis, or some ridiculously large number. But the simple fact is that for the people who want that, that's a very small subset of customers. That's a few telcos.
And it's also very incremental, though. It's still like it's a plateauing. Dave's talking about. It's like it wasn't like 45-degree improvement. It's just you know, a little bit.
Yeah. And the same thing with IPUs, DPUs. I call them DPUs. Intel wants to call them IPUs. Different companies want to call them smart NICs or whatever, but DPUs is what I'm calling them. Do you know why? DPUs, GPUs, TPUs, DPUs. Right? Yeah, and that's how it works, right? There's nothing intelligent about a network processor. It's just a data processing unit, graphics processing unit, TensorFlow processing unit, central processing unit. And that's entirely natural. So that's how I look at that. And the whole idea of a DPU has been around for 20 years. Zero innovation here. The difference here is there's no more advancements to be made around GPUs. There's no more advancements to be made around CPUs. There's no more advancements to, TPUs will advance, but that's a much different market than, and so the only gap that the technology silicon makers can skate into is the network. And largely because, as I said before, bandwidth increases. We've seen companies go from 10 meg to 1 gig to 10 gig to 100 gig on the server. Well, if you've got 500 servers, all with 100 gig or 50 gig or 25 gig each, well, all of a sudden you need, some way of moving the data off that bus. So the old PCI bus, you can tell me all about your CXL interface, and you can tell me about PCIe 7 with all of the channels and all that sort of stuff. But at the end of the day, your standard low-cost 50-cent, Broadcom silicon NIC chipset isn't the way forward. And the CPU being throttled, like they're talking 2 cores out of 4 in some cases being allocated to network processing, getting the data off. But that's not an innovation. That's like, duh, Captain Obvious just came up and slapped you on the upside of the head and said, give me we have to fix the networking problem because it's a problem. We're burning up too much power in the CPU just to move data off the bus. Okay, right. So all of a sudden the industry discovered the true believers of the smart NIC, which has been around for years and years and years. And yeah, okay, great, really exciting.
Smart NICs have been around in routers and switches for a long time.
30 years.
That's what we used to call line cards.
That's what we used to call load balancers.
Or load balancers or whatever. They were right. We would make a dedicated load balancer. Remember, we used to have web load balancers.
They were all x86 servers with a smart NIC and some drivers. Yep.
Right.
And a Cavium.
Right.
And a crypto chip.
Or something on it. But yeah, it's basically what we got today. Just slower.
Yeah, evolution, not innovation. That's another one of my favorites.
I call it asymptotic evolution. It's kind of like
they call it punctuated evolution, actually, is what they call it.
Just leveling off,
Yeah. So punctuated evolution is when things reach an equilibrium and they stay like that, and then all of a sudden there's something that happens that drives an inflection point. And I actually think that over the thing that I speculate, and my sense is somewhere around 2010 when we really started, and we were all involved in the software-defined thing, We were all
Yep.
there in the early stages. You guys were writing code, and I was
Figuring it out. Yeah.
flabbering my gums about it. And really, that was the inflection. That was the last punctuated equilibrium, was the arrival of software operations.
Yeah.
And the interesting part about that is that that's now normal, but I don't think there's any more transition now for another 10 years. I think it will be 10 years now of that iterating and us absorbing it as cloud or off-prem or on-prem or, all that. I mean, we're still seeing people pick up on observability, for goodness sakes. Still treating observability like an innovation. It's
Right.
2022.
Service assurance and that kind of thing, like it's rocket science. Like,
Yeah.
it's been going on for 20 years. You got to look
Yeah.
at, Heisenberg,
The biggest one that I'm seeing is something that I did 25 years ago, which is this network testing, where you actually have synthetic test agents littered around your network. And you can create synthetic tests, and they can do it. They call it digital experience monitoring, DEM. And what's happening now is that DEM is now becoming a standard feature in your network device. So Juniper, for example, ships that as Paragon Assurance, and it's a standard.
We ship these things too. Yeah.
Yeah.
At my place.
And we're also seeing it come in agents on clients. So you can now get software which then puts an agent onto your phone or your computer, and you can run synthetic tests. So, and that is now synthetic testing is amazing because you can schedule it to run on the weekend. And then you can schedule it to run in peak time, and you can see whether it's a peak issue or
when something's broken. You can remotely command it to just, let's try something. Yeah.
And that shift is, I find that much more innovative than anything else, because and it comes back to this subscription or persistent pricing, like this idea that you pay for it every month. You have to get down to the model where you're reducing the cost of operation. Because there's not, and this is, I'd be interested to hear what you guys think. Do you think there's enough young people coming into our field? Do you feel like there's enough staff?
Not really. I mean, I have a couple interns now who are fantastic, and I got a lot of applicants for my internships, but that was me. Around the rest of the company and friends of mine at other places, it's a little weird. There's a lot of folks thinking twice about this. I mean, there are people that want to be engineers and are interested in this, but all the train wrecks that everybody has seen, all they have to do is watch the Silicon Valley show for a couple episodes and go, is that really
just
what
interesting
I want to do
think.
for a living?
Well, one of the things that we're seeing is the vendors are starting to tell me, and obviously as the from what I do on the podcast and research, and is the vendors are briefing me and saying the big push behind AI ops is that there's nobody, these people can't hire staff to run these networks or to run the products that they've got. Now, that's been a sore point for me for 15 years, talking about operations and all that stuff. And but what they're actually saying is, they need to find ways to use software to operate the networking or the infrastructure because they can't get staff. And the answer is, of course, if I was, 20 years younger, what would I be doing? I'd probably be writing code for some company somewhere automating the network. I wouldn't be doing the network. I wouldn't be building out infrastructure. So I think that day two shift, that shift away from 20 years ago, we used to, get all bent out of shape about buying big pieces of hardware. Now all we're worried about is how to operate it. And I think the other thing that comes out of that is we're always configuring things now. 20 years ago, we used to configure something and walk away, throw the key, turn the lock, throw away the key, and walk off into the distance. Whereas now network, or infrastructure generally is constantly being tweaked. I can move the VM from here to here. That new machine's got a bigger CPU, so it'll run better. That network path's not working. I'll shift to this network path. That overlay isn't working very well. Do I need a bigger piece of hardware? That operational model is very different from what it was 20 years ago.
We've automated our outages.
Yeah.
So I think we'll punctuate the show right there. And Greg, we're going to drag you back in a couple quarters to talk about the day two stuff because it's super interesting. You've got great insight on it.
We got at least an hour left here.
Where can folks find you, man? And what are you going to be up to?
Well, I'm over at packetpushers.net, still publishing podcasts, same as I have been for 14 years. We just punched through 30 million downloads for the podcasts across all of
It's
our.
really good stuff. Check it out, folks,
Amazing.
if you haven't
Yeah.
checked their stuff out. It's the
I
top
will.
shelf.
I will pump my new podcast, which is called Heavy Strategy, and I got together with Jonah Till Johnson. She's the founder of Nemertes Research, and we go in a combative format and deliberately argue over strategy
She's
topics.
awesome. Yeah.
Yeah, and
Doesn't
so
take
heavy
any
strategy
crap from people. That must be fun.
It is a lot of fun, and if you can imagine, I am what we deliberately do is set up to take two sides of an argument, right? So it's a bit like a high school debate, right?
Yeah.
And we'll argue quite tightly, but politely, but nicely about something in less than 30 minutes, quite often in 20 minutes or less. And the goal here is not to help, is to give you ideas to think about, not to give you answers. There are no answers for this stuff. Everybody's situation is different. And so here what we're doing is saying, like, well, here's some ideas that we just spat out. Maybe that can get you started with your thinking. The Heavy Strategy, just search for it in your podcatcher, and it's a hell of a lot of fun. People are giving us really good feedback.
Wow, that sounds cool.
All right, definitely check that out. It'll be in the show notes, folks. And Greg, on behalf of the four of us, thank you so much again. It's great to see you.
Yeah,
you're the man.
Good to see you all too. We should get together on a Friday night for some off camera beers.
Absolutely.
Virtual
date. All right, folks. Everybody have a great day, evening, wherever you're at. And peace and love. Stay safe out there.